Hello, today I want to show you how to get the mean or standard deviation or doing a transpose for tensor or array with more than two-dimensional like three-dimensional tensor or more than that. Okay, let's into the Python, and then after that import torch and numpy, and for example we have a two-dimensional torch like this. Let's name it into tensor. And the size, let's check it. It will be like this. And for example, we want to get the mean for the first dimension. So we will have a two value. This it's easy. Oh yeah, I forget. We must define this tensor as a floating point. So we will not get error when we want to get the mean or standard deviation. And then after that, to get the mean for the first dimension, we're doing it like this. And for the second dimension, just define it as 1, and we get it like this. Since the dimension for the first and the second dimension is same, size for the first and the second dimension is same, the size of the mean for the dimension 0 and dimension 1 is same too. So yeah, get the standard deviation, just change this mean to SPD like this. To get for the second dimension, this, and that's it. Oh yeah, for the transpose, we do it like this. Okay. Oh yeah, we do it like this. Since we just have a first and a second dimension, what if we flip it? We do this, we get like this, we flip it, it's same. And that's it, how to get the mean, standard deviation, and transpose for the two-dimensional tensor. Now, what if we have a more than two-dimensional tensor? For example, let's define the numpy array first. And then checklist. Now we have this three-dimensional array. Let's convert this to tensor. And we get the tensor like this. Okay, the size of this tensor is like this. 2, 3, 4. Now, for example, yeah, example in the data analysis case, we want to get the meaning for the second dimension here, and if we use the logic for the two-dimensional tensor, we will do it like this, right? Mean I forget. Oh, yeah. If we follow the logic for two-dimensional tensor, we will do it like this. And if we do this, oh, I forget. Yeah, this is why in the first I doing like this here. I divide to float. This is because this feature tensor is the integer. So first we must convert it to the float tensor. And then after that, let's get the mean for the second dimension. What we expect is 3 value, right? So if we do this, we get something like this. This is not just 3 value, but what we get is it's two-dimensional tensor with size 2 times 4. So you see here, the original is 2 times 3 times 4. But if we get dimensional 1, the 3 is disappear. And if we change this to 0, we will get 3, 4. So here we can get the mean using the same way with the two-dimensional tensor. And to get the t mean, for example, we want to get the mean for the second dimension here is like this. So we must include the dimension. We must include all dimension except for the second dimension. Oh, yeah, except for the second dimension. So it will be like this. So if we do it like this, we get here the value of the tensor for tensor feature here. And if we want to, for example, we want to get 4 mean for the last dimension here, we do it like this. Include all the dimension except for the last dimension, and we get this. And for the first dimension, we do it like this. And this is the same for the standard deviation. Yeah. Now for the case of the transpose, and logically, when we imagine about transpose, it's in the two-dimensional, right? But what if in the three-dimensional? Actually, it's very simple. We see here in the way to transpose for the dimensional tensors, then two-dimensional tensor, it's like this. And it's same for the vectors here. And if we transpose for the first dimension and second dimension, it will be like this. Size, you see here, 3 and 2 is swapped. So yeah, what if we want to swap between first and last dimension? We do it like this. And the size will be like here. It's swapped. And that's it. It's very simple. Yeah, I know this is very simple, but for me, it's very, yeah, this is significant because before I know this way, usually when I have a three-dimensional tensor like this, I'm doing a looping, and Python looping is very slow. So the preferred way is the vectorized way like this. Okay, see you in another video. Bye.